بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 5.4 and it's about indefinite integrals. We will define the indefinite integral of the function f of x to be equals f of x if the derivative of capital F equals to small f. So this is the definition of the indefinite integral. So for example, what is the integral of x squared dx? It is x cubed over 3 plus c. Why? Because if we find the derivative of this function, which is x cubed over 3 plus c, we will get x squared. The derivative of x cubed is 3x squared over 3. So 3 cancels with 3. And the derivative of c is 0. So the derivative of this would be x squared. So that's why the integral of x squared is equal to x cubed over 3 plus c. So this is what we mean by this statement. Another example, the integral of secant square x dx is tan x plus c, because if we find the derivative of tan x plus c, derivative of tan is secant square and derivative of c is 0. So because of this, we say that the integral of secant square is tan x plus c. So this is the new notation we are going to use, and it is called indefinite integral. Pay attention to the difference between the definite and the indefinite integral. The definite integral is just a number. From a to b f of x dx, the result of this would be a number, where the indefinite integral will give you a function or family of functions because of the constant there. The connection between the indefinite integral and the definite integral is available from part 2 of the fundamental theorem. So that's the connection. The definite integral of fx of the function f of x from a to b is equal to the indefinite integral from a to b. If you remember, part 2 of the fundamental theorem of calculus says that definite integral from a to b f of x dx would be equal to f of capital F of b minus f of a, where capital F prime equals to f. This is fundamental theorem part 2 of calculus. Now what did we say here? We said if capital prime equals f, then we can write a capital F as integral of f. So capital F here, this one, I can write it capital F of x, okay, from a to b, or capital F can be written as indefinite integral of f of x dx from a to b. Okay, so this is the proof, the relation between the definite integral and the indefinite integral. So we can have now formulas to find the indefinite integrals. First, if c is a constant and this is f of x, these two rules, we studied them for the definite integral, and they are still true here for the indefinite integral. You can take the constant out if you have f of x, c multiplied by f of x, and you can distribute the indefinite integral if there is a plus or a minus, okay? Now the new formulas, what would be the integral of k dx? When I say integral, it's indefinite integral, okay? So what is the integral of k dx? Well, it would be kx plus c. Why? Because if you find the derivative of kx, it is k, and the derivative of c is 0. So the derivative of kx plus c is k. So integral k dx would be kx plus c. What would be the integral of x to the power n? It would be x to the power n plus 1 over n plus 1 plus c. So we add 1 to the power and we divide by the power. But of course, n plus 1 cannot be 0. So if n cannot be negative 1. Why this formula is correct? Because if you find the derivative of the right-hand side, you will get x to the power n. Okay. What happens if n is negative 1? We will have x to the power negative 1. And x to the power negative 1 is 1 over x. So what is the integral of 1 over x dx? It would be ln absolute value of x plus c, because the derivative of this is 1 over x. So we need to memorize these formulas to be able to solve the questions about indefinite integral. Integral of ex is ex plus c because the derivative of this is ex. Integral of b to the power x, the exponential function, is b to the power x over ln b. Remember, the derivative of bx, b to the power x, the derivative is b to the power x times ln b. That's the derivative. So if you find the derivative of bx here, it is bx times ln b cancels with ln b, and you get bx, b to the power x. So integral of b to the power x would be bx over ln b plus c. Integral of cosine is sine because the derivative of sine is cosine. Integral of sine is negative cosine because the derivative of cosine is negative sine. Integral of secant square is tan because the derivative of tan is secant square. Integral of cosecant square is negative cotan because the derivative of cotan is negative cosecant. Integral of secant tan is secant because the derivative of secant is secant tan. And always there is a plus c because the derivative of c is 0. Also, the integral of cosecant cotan is negative cosecant because the derivative of cosecant is negative cosecant cotan. The derivative of tan inverse is 1 over x squared plus 1. That's why the integral of 1 over x squared plus 1 is tan inverse. The derivative of sine inverse x plus c is 1 over square root of 1 minus x squared. That's why the integral of 1 over square root of 1 minus x squared is sine inverse x. The derivative of cosh is sinh, and the derivative of sinh is cosh. So the integral of sinh would be cosh, and the integral of cosh would be sinh. Let us solve some examples. Find the general integral, or find this integral, okay, the general indefinite integral. Well, I can write this integral as integral of 10x to the power 4, and I can take 10 as a common factor, not a common factor. I can take it out because it's a constant. And I can distribute the integral. I can also take 2 outside because it is a constant. And now I use the formulas. What is the integral of x to the power 4? According to this formula, x to the power 4 would be x to the power 4 plus 1 over 4 plus 1. So it is x to the power 4 plus 1, which is 5 over 5, minus 2 times. What would be the integral of secant square? According to this formula, the integral of secant square is tan. So integral of secant square is tan x. Then I add c. You only add c once, because if you add c1 here and c2 here, then c1 plus c2 could be c. So even if you have 10 integrals, at the end you just add c. One c is enough. Now to simplify this, I can cancel 10 with 5 or divide 10 by 5, and it would be 2. So the answer would be 2x to the power 5 minus 2 tan x plus c. To check your answer, find the derivative of this. You will find that the derivative would be this one, this function. So 2 times 5, 10x to the power 4, this one, minus 2, derivative of tan is secant square, and derivative of c is 0. So in fact, our solution is correct. Find this integral. Now, if you look to the formulas, you have to memorize the formulas, and you have to always compare the question to the formulas. So here I have cosine theta over sine square. There is no formula here in which I have cosine over sine square at all. I have integral cosine, integral sine, but there is no integral cosine over sine square. And you cannot write it integral cosine over integral sine. That's not correct at all, because integral, you can distribute the integral if there is a plus or minus. But if there is a product or division, you can't. There is no probability that allows you to do that. So what can I do? You have to think a little. You have to try to write this integral in a form in one of these formulas. So if you think here, you find that I have one cosine up and sine square down. So in fact, sine square is sine times sine. X square is just x times x. Okay. Now I also can write this as cosine theta over sine theta times 1 over sine theta d theta. Because if you multiply these two fractions, then you get cosine theta times 1 cosine, sine theta times sine theta, you get the denominator. So I can write this like this. Then what would happen? What is cosine over sine? Cosine over sine is cotan, and 1 over sine is cosecant. So now this integral is equal to integral cotan times cosecant. Is there a formula for integral of cotan times cosecant? Yeah, this one. Integral cosecant cotan is negative cosecant plus c. So the answer would be negative cosecant theta plus c. So that's the integral. That's the answer. Another question, and notice that this is a definite integral. All right, this would be equal to the indefinite integral of this. We need the integral of x cubed. Well, integral of x cubed is x to the power 4 over 4. And I can write it from 0 to 3 here, or leave it at the end, minus 6, you take it out, and you find the integral of x. Integral of x, you add 1 to the power, and you divide by 2 from 0 to 3. This is the relation between the definite integral and the indefinite integral. You find the indefinite integral and then from 0 to 3. Now you should replace x here by 3 minus replacing x by 0. Or I will do it like this. I will take 1 over 4 out, and then x to the power 4 from 0 to 3 minus 6 over 2 is 3, and x squared, I'll take it from 0 to 3. So I will have 1 over 4 times. Now replace x by 3. So 3 to the power 4 minus replace x by 0, so 0, minus 3 times. Now replace x by 3, so 3 square or 9 minus 0 square or 0. So the answer would be 3 to the power 4, which is 81, over 4 minus 3 times 9 is 27. So that's the answer of the definite integral. Another definite integral, I need to find the indefinite integral of this function. But I will write it like this. Let me write it first as follows. I can take 2 out, okay, if you like. X cubed dx minus 6 integral from 0 to 2 x dx. I can distribute the integral if there is a plus and minus. Plus 3, I'll take the 3 out. Integral of 1 over x squared plus 1 dx, okay, from 0 to 2. So this would be equal to, this is 2. What is the indefinite integral of x cubed? It's x to the power 4 over 4 from 0 to 2 minus 6. What is the indefinite integral of x? It's x squared over 2 from 0 to 2. And then plus 3 times. What is the indefinite integral of 1 over x squared plus 1? If you go to the formulas, indefinite integral of 1 over x squared plus 1 is tan inverse x. So it would be 3 times tan inverse x from 0 to 2. So I will have the following. 2 over 4 is half, and x to the power 4 from 2 to 0. So I will replace x by 2, so I will have 2 to the power 4. Minus 0, there is no need to write minus 0. Minus 6 over 2 is 3. Replace x by 2, so I will have 2 square or 4 minus 0. I'm not going to write minus 0. Plus 3 times tan inverse 2 minus tan inverse 0. Now here, 2 to the power 4 over 2 is 2 to the power 3, which is 8. And 3 times 4 is 12. And be in radian mode and in the calculator, and ask the calculator to find, if you ask the calculator to find tan inverse 0, you will find the answer is 0. So this is in fact also 0. So I will have 3 tan inverse 2. So the exact answer of this definite integral 8 minus 12 is negative 4 plus 3 tan inverse 2. If you want to find an approximation, you can ask the calculator to find tan inverse 2 and multiply by 3, okay, and add -4, or just write -4 plus 3 tan inverse. So the answer would be -0.6785. So I will write it 9. So this is the answer. This is the indefinite, the value of the definite integral. Interpret the result. The result is negative. So this is the net area. If the result of the definite integral is negative or 0, then it is the net area. The last example would be again a definite integral, but here to find the indefinite integral of this, I can't. There is no formula to deal with this, and I can't divide. Okay, it's not the integral of the numerator over the integral of the denominator. This is not correct. So what should I do? I should simplify this. Let us see how can we simplify it. I can take, or let me just write it, 2t square over t square. I can do that, plus t square square root of t over t square. So I can distribute the numerator over the denominator, minus 1 over t square, okay, dt. And now I can write it from 1 to 9. Now t square cancels with t square. I will have 2 plus t square cancels with t square. I will have square root of t minus 1 over t square dt. Well, I can find the integral of 2, but how can I find the integral of square root of t? There is no formula here to deal with integral of square root of t. But if you think carefully, this is x to the power n. So if you can write square root of t as t to the power n, then you can use this formula. Also 1 over t square. This is 1 over x, but I have 1 over t square. So if you can write it t to the power n, then also you can use this formula. So pay attention to this important point. So in fact, I can write this as integral from 1 to 9, 2 plus square root of t. I can write it t to the power half. Then I'll be able to use the power formula, x to the power n formula, minus, if you take t square up, you can write it t to the power -2. And once you write it t to the power -2, you can use the formula of x to the power n. So what is the indefinite integral of these three terms? The indefinite integral of 2 is 2t, because this is dt with respect to t, and from 1 to 9, plus what would be the integral of t to the power half? It would be t to the power half plus 1. Half plus 1 is 1.5, or 3 over 2 over 1.5. You can write it over 3 over 2, or you can write it multiplied by 2 over 3, because divided by 3 over 2 means multiplied by 2 over 3. So I can write it like this, from 1 to 9, minus t to the power -2. You add 1 to the power and you divide by the same number from 1 to 9. So I will write it 2 times. Now t, replace it by 9, minus, replace it by 1. 2 times 9 times 2 is 16. 2 times 9 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 is 16. 2 times plus 2 over 3 times. Replace t by 9 minus replace t by 1. 1 to the power 1.5 is just 1. Notice this minus, you can multiply by this minus, and it would be plus. Then you have 9 to the power negative 1, which is 1 over 9, minus 1 to the power negative 1, which is 1. And you can use the calculator to help you to evaluate this. 9 minus 1 is 8, 2 times 8 is 16. And if you use the calculator to find 9 to the power 1.5, the answer is 27. So 27 minus 1 is 26. 26 times 2 would be 52. So I will have 52 over 3. 1 over 9 minus 1 by the calculator is just negative 8 over 9. And then you can add all of these in the calculator and write the answer. The answer is 292 over 9, or 32.4444. So I can write it like this. This is the end of this section. I hope you enjoyed the lecture. Have a nice time.